So let's talk about some related rate problems and how to actually work them. So I have a problem here. It reads, an airplane is flying on a flight path that will take it directly over the tracking station. The airplane is flying at an altitude of 5 miles, s miles from the station. The distance s is decreasing at a rate of 360 miles per hour when s equals 13. What is the speed of the plane? Okay. So let's write down some givens here, and then we will start working the problem. All right, so I know that my ds dt, they gave me my ds dt, the change in my distance from the plane to the station, and that is that it is decreasing at 360 miles per hour. It tells me that s is going to be 13 because we have to figure out this is miles. And it tells me its altitude is 5 miles. So we're going to have some sort of diagram like this. It's going to be a right triangle. My altitude is 5 miles. I have a plane right here. Let's call this x. It's flying this way, so this is the dx dt. And we don't know that. That's what we're looking for. It did give us a ds dt, which is our negative 360 miles per hour, and then we have s here. So let's take this diagram and let's go ahead and figure out what dx dt is. Okay, so I read through this diagram so I have some room to actually work. So we have to think of an equation that we know that's going to relate s with x, because we're actually looking for dx dt. That's what we're looking for. And then we're actually looking for the speed of it. So we'll take the absolute value of this once we find the answer. All right, so let's see. It's a right triangle with 3 sides. Hey, I know Pythagorean theorem. So I can actually say s squared equals x squared plus 5 squared. Okay. So there's an equation, a differentiable equation, with x and s related. So let's take the derivative of this. So I'm going to have 2s ds dt, because we're going to take the derivative with respect to the time. This gives me 2x dx dt. Of course, the derivative of a constant is nothing more than 0. Well, we're looking for dx dt, so let's solve this and get a formula for dx dt. When I do this, I get dx dt equals, well, this is going to be s over x ds dt. All right, so let's look and see what we have. We have an s, we have a ds dt, but we don't have an x. But I know when s is 13, I can find this by you doing Pythagorean theorem. So I can do 13 squared minus 5 squared, take the square root of it, and that's going to equal my x. Well, when you end up doing this math, we end up getting this 169 minus 25 equals x. This is the square root of 144, which is x, therefore x 12. So now I have an x, I have an s, I have a ds dt, plug it in, I have my dx dt. So I have my dx dt equals my s right here, which is 13 miles. 13 miles. My x divided by my x, which is 12 miles. So a mile over a mile will cancel. So this is basically now unitless at 13 over 12 times my ds dt, which is a negative 360 miles per hour. Therefore, my dx dt will be in miles per hour, which makes perfect sense. So when we crunch these numbers, we get a negative 390 miles per hour. Now, this is the velocity of it. Speed is the absolute value of the velocity. So to find the actual speed, we're going to take the absolute value of that. So the speed of the airplane is 390 miles per hour. Not a terribly bad problem. It's really Pythagorean theorem. If you have three sides, you can use Pythagorean theorem, and you just take the derivative of Pythagorean theorem and kind of work from there. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.